Good morning, my dear students. And today we're going to discuss about the basic operations on the signals. This is myself, Vijay Shankar from Electronics and Communication Engineering Department, Chipral Engineering College. Let us start the today's session with the topic of the basic operations on the signals. Basic operation on the signals. There is 6 types of operations on the signals. It is time shifting, time reversal, time scaling, amplitude scaling, signal addition, signal multiplication. In these 6, the first 3 operations corresponds to transformation in independent variable, the T or N of a signal. The last 3 operations corresponds to transformation on amplitude of a signal. Coming to the first one, the time shifting. Mathematically, the time shifting of a continuous time signal x of t can be represented by y of t is equal to x of t minus capital T. The t is a variable time period and capital T is a fundamental period. The time shift of a signal may result in time delay or time advance. The time shifting of a signal may result in time delay or time advance. In the above equation, the y of t is equal to x of t minus t. If t, capital T is positive, the shift is to the right, and then the shifting delays the signal. When the t is positive means x of t minus t is a positive value 1, 2, 3 and so on. The shift is to the right and then the shifting delays the signal. And if t is negative, the t minus of minus t, nothing but the t plus t. If t is negative, the shift is to the left. And then the shifting advances the signal. Okay. The signal x of t delays version and advanced versions. This is a delay version of figure B here, as shown in the second one, x of t minus t, and advanced version x of t plus t. Shifting a signal in time means that a signal may be either advanced in the time axis or delayed in the time axis, because it's a time shifting. Only there is a changes occurs in the time only. Means moving towards right side, moving towards the left side linearly. There is no changes occurs in the amplitude of the signal, the given input signal x of t. Only it is shifted with the fundamental period of the t, capital T, either towards right as delayed in the time axis or towards the left side advanced in the time axis. Okay, my dear students. And time reversal or folded function. Time folded. The time reversal is also called as a time folded of a signal x of t can be obtained by folding the signal about t is equal to 0. This operation is very useful in convolution. It's a convolution, the integral minus infinite to infinite x of t and h of t minus tau deta. It is the equation for the output function y of t. Y of t is equal to x of tau and h of t minus tau beta. Okay, it is a convolution. It is another topic We can discuss in the later. It is denoted by x of minus t, the folded function. For negative values of x, we'll get the positive values of the x of t. In the negative values of t, the positive values of t, the amplitude of the signal, you get in the negative real axis. The negative real axis value is getting in the positive real axis. Nothing but the folded function, or the time is reversal. Time reversal. It is of time by replacing the input variable or independent variable t by minus t. T by minus t. Folded is also called as a reflection of the signal. A reflection of the signal. Reflection. The negative to the positive, positive to the negative. Okay. At t is equal to 0. X of t changes as x of minus t. You can call it as a time reversal or folded function at t is equal to 0. If it is a t is equal to minus 1, the t is equal to minus 2, or different folded functions are there. There is a lot of difference in the folded. At origin, we can fold x of minus t. At minus 1, we can fold it is x of minus t minus 1. Okay. Let's take one example. I will show here. Now I am taking the discrete format. Discrete time signals. Discrete time signal. Okay. Assume a step function. Mu of not the step function. Let us take a ramp function r of t. Not the r of t, because it is a n r of n with n. Okay, there's a time discrete time signals. Variable is a n. For 0, the value is 0. For 1, the r of 1 is also 1. And for 2, r of n is also 2. 3, r of n is also the 3. Okay, and so on. This increases. Correspondingly, n increases, r of n is also increases linearly. Linear signal. The ramp signal we can call it is a ramp signal, or also linear signal. Linear signal. Okay. Now the folded function of r of minus n. R of minus n. R of minus n is nothing but r of minus n. That is a plus or minus 0 also. It is a minus 0, let us take. Minus 0, or it is a plus 0. It is a 0 is there. If folded at the 0. Folded at the 0. Means 0 is a 0 only. There is no any change in the 0 value. The 1, 2, 3. So on the n values. I'm taking here the minus 1, minus 2, minus 3. Okay. In the folded version, the value of 1 here it is a 1, but there is no any minus 1 is a 0 here. Minus 1 is a 0. This one is a 0, minus 1, 0, minus 2 is also 0, minus 3 is also 0. Okay. Now, in the folded version, minus 1, 0 will get at the plus 1. But at 1, there is a 1 is there, it will get at the minus 1. Okay, that is a folded. Now, what is a minus 2 here in the R of n? 0. That value will get it here at the 2. And the positive value of 2 in the R of n is a 2. Now, I'll get minus R of n at minus 2. Okay, minus 2. And minus 3. What is a minus 3 here? 0. That 0 will get in the positive value. And at positive value of n, the R of n is a 3. That will appear at minus 3 in R of minus n, 3. Okay. Now, this is a folded function of R of n. The values in the positive real axis will get in the negative real axis, and the values in the negative real axis will get in the positive real axis. But it is a folded at t is equal to, not the t, we are not using the t here, n is equal to 0. Means R of n minus n, nothing but R of minus n plus R minus 0 here. Okay. Now, I am taking here another example, R of minus n minus 1. Let us take R of minus 1 minus n. Minus n and minus 1. Okay. Is nothing but R of minus of n plus 1. N plus 1. What is the R of n plus 1? Before that, we have to know R of n plus 1 what is. Okay. Take here. Where is this? R of n plus 1. R of n plus 1. N plus 1 is an advanced function of the ramp signal. Advanced function. Advanced means the value of R of n at n is equal to 0 will get at the minus 1. The value of at n is equal to 1, the R of 1 value will get at the 0. We shift it towards left side. Minus 3, 0, minus 2, 0, minus 1 is also 0, but now the 0 is 1. 0 value is 1, 1 value is 2, because shifted towards the right side, not the right side, sorry, left side, and 2, 3 value. Okay, so what is a 4 here? Let us assume the 4 is also 4. Okay, right up that one. Shifting of one sample. The value at n is equal to 1, the R of 1 value at n is equal to 1. Now we'll get at n is equal to 0. And the value of R of n at n is equal to 2, we'll get at n is equal to 1 here. The value of R of n at n is equal to 3, now we will get at the 2. Means one sample is shifted towards the left side. This advanced function. Now see, the same thing, R of n plus 1, R of n, we draw the R of minus n, folded at the 0. Folded at the 0. Now, R of n plus 1, R of minus of n plus 1. Minus of n plus 1 means the folded occurs at here, you see, at the minus 1. Okay, at the minus 1. See, otherwise, r of minus n, the minus 1, r of minus n minus 1 means r of n plus 1, as this is shifted towards the left side, as it shifted towards the left side. Okay. R of minus 1. Left side means minus 4, minus 2, minus 1, and it is a 0. Alright, add the minus 1. Now, you can observe here, 0 is a 0, and minus 1 is also 0 here, and minus 2, 1, minus 3, 2, minus 4, 3. Okay, my dear students. You can see it is folded at minus 1. Folded at the minus 1 means r of minus n minus 1. Minus 1 means shifted towards the left side. Shifted towards the left side. Minus, whenever you are using in the folded function, shifted towards the left side. But coming to the r of n, the folded version, not the folded version, if it is a minus, shifted towards the right side. Don't confuse my dear students here. R of n is a normal signal, r of minus n is a folded signal. When the normal signal r of n, nothing but is a ramp signal, n minus 1, r of n minus 1, minus 1 means that k value. Okay, let us see here, r of n minus k. This is generalized shifting operation. That k is a positive, k is positive means n minus some value, minus values only. Okay, n minus, the k is positive values, shifted towards the right side. If k is a negative, means n plus k, shifted towards the left side. But here, r of minus of n minus k, r of minus k, if k is positive value means here it is shifted towards the right side, but here it is shifted towards the left side. Okay, if k is positive. If k is negative, in the r of n normal signal, it is shifted towards the left side, and here the k is negative, r of minus n plus k. Plus means towards the right side, the folded function, the reverse, whatever here. Okay, so r of minus n minus 1. So I take the r of minus 1 and one sample is shifted towards the left side. One sample is shifted towards the left side when the k is positive value. When the k is a positive value for the folded function. Okay, now you can observe these two, r of n plus 1 and r of minus of n plus 1. R of n plus 1 and r of minus of n plus 1. Means r of n and r of minus 1 means folding occurs at the 0. Folding occurs at the 0. There is no any change in the 0 value. 0 is a 0 only. That 1 will get here, 2 will get here, and the 3 value will get here. Same thing, r of n plus 1. Now it is folded, occurs at the minus 1. Folded occurs at the minus 1. Means whenever the fold occurs at the minus 1, the minus 1 value, there is no any change. This 0 will get at the 2, and 1 value will get at the 3, and 2 value will get at the 4. Understood, my dear students? Okay, is a folding occurs at the minus 1. Folding occurs at the minus 1. So, with another example, we can understand. I take r of n plus 1 is the same thing here, r of n plus 1. Now, I draw r of minus n minus 2. Let it be here. So 0, 1, 2, 3, 4 like this, and -1, -2, -3, -4, and the -5. Let it be. So what happens here? The R of n plus 1. It becomes of R of minus of n plus 1. Now it is R of minus of n plus 2. N plus 2. Okay. Means R of minus of n plus 2 with R of minus n you can draw. The signal is shifted towards the left side with the two samples. Shifted left side with the two samples of R of minus 1, or otherwise shifted one sample of R of minus n minus 1. So 1 minus 1, the 0 value will get here. Minus 2, the value of 1 will get at the minus 3. And the value of minus 3, the 2 will get at the minus 4. And value of minus 3 at n is equal to minus 3 will get at the minus 5. One sample ahead. Okay, you see? What is a minus 1? 0. Now the minus 2 is also 0. Minus 1, 0. 0 is a 0 and 1 is a 0. And minus 2 is also 0. You get the 3, 1. And at the 4, minus 4, you get at the 2. And minus 5, now it is a 3. Okay. R of minus n minus 2. Minus n minus 2. Now here the minus of 2 is positive value here. K is a positive in the folded function shifted towards the left side. Okay. But normal function, positive value is the right side. Okay. Don't confuse here, my dear students. But compare here. See where it is a folded. R of minus of n plus 2. R of minus of n plus 2. Okay. So see R of n plus 1. N plus 1 means folded at the minus 1. We'll get 1 at the minus 2, 2 value at minus 3, and 3 value at minus 4. Okay. R of minus 2 means a folded occurs at the minus 2. Folded occurs at the minus 2 means the 0 is there here. That the 0, there is no any changes occurs. 0, minus 2 for R of n. This goes towards add the 2 only, the folded function at the 2. The 1 will appear at the minus 3. 2 will appear at the minus 4. And 3 value R of n plus 1 will get at the minus 5. Okay. The folded occurs at the minus 2. Folded occurs at the minus 2. You see, folded occurs the minus 2. Then the minus 3 value, here minus 3 value is a 0. Okay, minus 3 value. After here the folded, the 0 will appear here, and the 1 is appears here, and the 2 is appears here, and the 3 is appears there. Means R of minus n, the folded occurs at the 0. R of minus of n plus 1, the folding occurs at the minus 1. Okay, minus 1. And R of minus of n plus 2. R of minus of n plus 2, the folded occurs at the minus 2. Folded occurs at the minus 2. There is no change in the minus 2. The 3, here the folded occurs means the 0 value will get here, and 1 value is getting at the 3, and 2 value at the 4, and the 3 value at the 5. Okay, my dear students. The folded occurs for at the minus 2, at the minus 2. Again, you can let it be the little bit confusion. I will draw the R of n here. R of n. R of n. What is R of n? 0, 1, 2, and 3. 1 is occurs here, 2 occurs, and 3. Minus 1 is 0, and 0 is also 0. Minus 2 is also 0. Minus 3 is also 0. Now I am taking this R of n, the folded version, with the samples of n2. Samples, the two samples, let it be the R of n plus 2. R of n plus 2. Okay, what is R of n plus 2? Moves towards left side. Moves towards the left side. This value. Two samples in the left side. Because I am writing for the normal R of n, the ramp function only. The 0 is a 0 and 1, not the 1, it is a minus 1. Minus 1 is a 0, minus 2 also here. Minus 1 and minus 2. Okay, the two samples, 0 will get here the 1, that is R of n plus 1, and that 0 will get here the minus 2, that is a two samples here. 0 means 1 will get here, and at the 0, 2 will get, and the 1 is a 3. Okay, my dear students. And the 2, 3, and so on. So how many samples will get? The two samples is empty here in the right hand side because it is shifted towards the left side of the two samples. So minus 2 is a 0, minus 1 is a 1, 0 is a 2, so here the 2, and 1 is a 3. And here R of n plus 2. Now I draw here R of minus of n plus 2. Minus of n plus 2. Means the folded occurs at the 2 here. The folded occurs at the 2. Means this one. You see the folding occurs at the minus 2. See these total values will in the negative real axis, and this total minus 3, minus 4, whatever the values are there, that will get at the remaining values from minus 1, 0, 1, 2, and 3. You see at the folded means this 1 will appear at the minus 3. You see minus 3. And 0 will appear at the minus 4. 0 value. What is the 0 value? N is equal to 0 value? The 2. That will appear at the 4, minus 4. And at n is equal to 1, the R of n plus 2, the value is a 3, that appears at the minus 5. Okay, my dear students. See, to get R of minus n minus 2, the folding occurs at the 2. Okay, that is a minus 2. In the previous case, R of minus 1 n plus 1, R of minus n plus 1, the shifting operation towards the left side as a 1. Now the folding occurs at the minus 1 to get this response. Okay, minus 1 means what is the 0 value here? 1. That 1 will appear at the minus 1, minus 2. And what is the value at n is equal to 1? The 2. That 2 value of R of n plus 1 will get at the minus 3. See what the minus 3. And the value of R of n plus 1 when n is equal to 2, that will appear at the minus 4. Okay, means the folded occurs at minus 1, and in this case the folded occurs in the 0. Okay, because minus n minus 0 or plus 0, whatever it is, both are the same. The folding occurs, the folded at n is equal to 0. But here the folded at n is equal to minus 1 in this function. The folded at n is equal to minus 1 means the folded occurs here. The total values in the dotted lines above towards the dotted lines, these values are in the left hand side and these values will get in the right hand side. Folded at n is equal to minus 1. In this, folded at n is equal to 0. Coming to here, r of n minus 1, comparing of these two, r of n plus 2 and r of minus of n plus 2. What is r of n plus 2? This is a value we got from the r of n. Now, the folded occurs at the minus 2. The folded at n is equal to minus 2. N is equal to minus 2 in this function. So the values, the total values to right hand side from the dotted lines here, the 1 appears here, 2 appears here, and the 3 is appears. Okay, this is a reference. 2 is a 0, and 3 is a 1, and at the minus 4, the value is a 2, and at the minus 5, the value is a 3. Okay, so r of n plus 3, r of minus of n plus 3 means where you have to fold in the r of n plus 3, the folded occurs at the minus 3 to get r of minus of n plus 3. Understood, my dear students? R of n, r of minus n, folded occurs at 0. R of minus of r of n plus 1 and r of minus of n plus 1. The folded occurs at minus 1. R of n plus 2 and r of minus of n plus 2. The folded occurs at minus 2 and so on. Understood, my dear students? Now coming to the same thing, to get r of n minus of minus k for the negative values of k, r of minus k. For negative values, we'll get r of minus n minus k. Already we completed, and r of minus n plus k. We see in this one, r of minus of n plus k. We already completed k is equal to 1 and k is equal to 2. Or the k is equal to 0 also. K is equal to 0. Okay, these are functions. At k is equal to 0 means we'll get r of minus n, this one. And k is equal to 1 means r of minus of n plus 1. And k is equal to 2, this function is r of n plus 2. Okay. Okay, my dear students, n plus 2. So for the k values of positive values, and now this r of minus n minus plus k is r of minus, you can take n minus k. N minus k. Means k is at minus 0 and k is at minus 1 and k is at minus 2 for negative values. Okay. For negative values of k is minus 0 means minus n minus 0. K is equal to minus 1 means minus n minus of, okay, the minus values, and k is equal to minus. So on. Okay. And for k is equal to minus 0, this becomes of r of minus of n is a plus only, it is a minus of minus minus you can take it as a plus, and r of minus of n, k is a negative here. In this substitute, the k is a minus 1. So before that, is r of minus n, and the k is a negative value, k is a minus 0. This becomes also the r of minus n only. And r of minus n, k is a minus 1 here. K is a minus 1 is a minus 1. So that is equivalent of r of not equal, the k is a positive value after here. The k is a negative value. So k is a positive and the k is a negative n minus n plus 1. N minus n minus plus 1. And it is a plus 0. R of n, not is a plus, sorry. Becomes of r of minus n and r of minus n, take the common of minus 1, then it becomes minus n plus k. Okay, and r of minus of n minus 2, so it becomes of r of minus n, minus into minus is a plus. Okay, in this substituting the minus of plus k, not the plus, it's a minus only. In this case, how we get the function moves towards the right side, you can draw that one. Now, I am taking the r of n. R of n as n values. 0 is a 0, 1 is a 1, 2 is a 1, 2 is a 2, and 3 is a 3. Okay, magnitudes. Minus 1 is a 0, minus 2 is a 0, and minus 3 is a 0. Okay, and minus 3, minus 2, minus 1, 0, 1, 2, and the 3 are of n values. So r of previously we can take r of minus n plus 1. This becomes of r of minus, you can take n minus 1. N minus 1. Previously you can see r of minus of n plus 1 we got. Now it becomes r of minus of minus 1. Okay, r of minus of n minus 1. N minus 1 you can write as first of all r of n minus k. R of n minus 1. R of n minus 1. N minus 1 shifting off towards right side of one sample. 1 is a 0 is a 0. 1 is also 0. 2 is also 2 is 1. It's 1. And 3 is a 2. And 4 is a 3. So one sample moves towards the right side, r of n minus 1. R of n minus 1. Now the folded version of r of n minus 1. The folded version of r of n minus 1 means we can fold this function at 1. Fold the function at 1 minus 2. R of minus 1 means minus n plus 1. Before that, it is also minus n plus 1, minus of n minus 1, minus of n minus 1, the folded function. The folded function of this one, add the 1 only, add the 1. So you can take a 0 here, and 1 is, there is no change because it is a folding at the 1. Whatever the 2 value here, that 2 values appears at the 0. The 2 value appears at the 0, 1, and minus 1. Here the minus 1 is a 0, minus 2 is a 0, and minus 3 is a 0. So we are folding at the 1, means the value at 1 is no changes. 2 at n is equal to 2, that appear in the 0. When n is equal to 0, the value is. And what is a 1? The what are the minus 1 value will appear at the 2, because it's a folding version. So 2 will get here, and the 3 value of x of n minus 1, the 2, add the minus 2, and it is a 0. And the 4 value, it appear at the minus 2, 3, and this value is a 0. Means the folded occurs at the 1. So 2 value will appears at the 0, 3 value appears at the minus 1, and 4 value appears at the minus 3. Minus 2, not the minus 3, minus 2. So minus 3 value. Means now you can see it is a shifted version of R of minus of n minus 1, or R of minus n plus 1. Minus n plus 1. Only the one sample towards the after the folded version of. We can compare this R of minus n, R of minus n. What is R of minus n folded function of this? 0, we are folding at the 0, there is no change of the value. Minus 1 is a 1, minus 2 is a 2, minus 3 is a 3. 1, 2, and 3. And 1 is a 0, 2 is a 0, and 3 is a 0. The values of 1. Of R of minus n plus 1. R of minus n plus means in the normal signal shifting towards left side. But in the folded function, shifting towards right side. See here, 0 value will appear in the 1, and minus 1 value is appear at the 0, and minus 2 values appear at the minus 1, and minus 3 values appear at the minus 2. Understood, my students? And now we can get one idea how the folded function and the normal function, the shifting operation or the folding operation after the folded, where it is a folded is a very important. R of minus n means folding at occurs at the 0. R of minus n minus 1. R of minus n minus 1 means the folded occurs at the minus 1. Okay, the folded occurs at the minus 1. See here, the folded occurs at the minus 1. R of minus n minus 1. But R of minus n plus 1, minus n plus 1, the folded occurs at the plus 1. Folded occurs at plus 1. See, occurs at the plus 1. If suppose R of minus n minus 2, minus n minus 2. You see, R of minus n minus 2. Not the minus. Where it is here, over here. R of minus n minus 2. R of minus n minus 2, the characteristics or the graphical representation you get, the folded at the minus 2 of R of n plus 2. Minus 2. The folded occurs at the minus 2. Means the 1 values appears at the minus 3, 0 values appears at the 4, and the 1 values appears at the 5. A similar way, the R of minus n plus 2, R of minus n plus 2. Plus 2 means where the folded occurs at the 2. The folded occurs at the 2. Let it be see how it looks like R of minus n plus 2. R of minus n plus 2. For this, the folded version of R of n minus 2. R of n minus 2. So before that, you can draw this as R of n minus 2 function. N minus 2. For this R of n, shifting 2 samples to the right side. 0 is a 0, 1 is also 0, 2 is also 0. Because 1 sample is moved here. 3 is 1, 4 is 2, 5 is a 6. Not the 5 is 6, 5 is 3. Okay. With this reference, to draw the folded function of R of minus n plus 2. R of minus n plus 2, the folding occurs at the 2. Okay, the folded at the plus 2 value. Means there is no any change in the 2 value. Okay. There is no any change in the 2 value. 2 is a, what is the 2 value here? The 0. 2 is a 0. But what is a 1? After folding 1, the 3 value will get at the 1. So 1, 2, 3. 1, here the 2, and at minus 1 we get the 3. 1 and the 2. Means the folding occurs at the 2 here. Folding occurs at the 2. Understood, my dear students? Like this, we can draw the characteristics of R of n, R of minus n, and R of n minus 1 as of minus of n minus 1, R of n plus 1 is R of minus of n plus 1. Means R of n is a normal function, it is a folded function. R of n minus 1 is a delay function, moves right side here, and R of n plus 1 is advanced function, moves left side. But here, the R of minus n is a folded signal. R of minus of n minus 1. Minus of n minus 1 means shifting left side here. Left n minus 1. And R of minus of n plus 1 is the right. The reverse. Minus of n minus n plus 1. Minus n plus 1. Minus n minus 1. Minus, the minus means here is a, already we seen, is the characteristics. R of minus n, the folded version of these two. R of n plus 1 and R of minus of n plus 1. Minus of n plus 1 is towards left side, it is a plus. Okay, moves towards the left side. R of minus n minus 1. R of minus n minus 1. Minus n minus 1 is the left side. Sorry, here. This is the left. Since it is a, this one is a left, since R of it is equivalent of minus n minus 1. So minus is represented is a left here, minus is represented for the normal function is a right here. And this is the R of minus n plus 1. Plus is a left here, now it is a right. It is a right shift. The right shift of the folded function, not the normal function, my dear students. The folded function we draw, when we get it is a R of minus n plus 1, R of minus n plus 1. You see, R of minus n plus 1. Minus n plus 2, shifted towards the left side. Shifted towards the left side. Minus n plus and minus n minus 1. Minus n minus 1. You see the minus n minus 1. Minus n minus 1 is towards left side. Minus n plus 1 towards the right side. Okay. Now we got some idea on this by taking of the discrete time functions of the shifting operations as of time reversal and using the time shifting, time reversal and the time shifting. Now coming to the amplitude scaling, there is a change occurs in the amplitude only, there is no changes occurs in the time. Time is always the same and only the changes occurs in the amplitude, where y of t is equal to a into x of t, where a is a positive, nothing but a is greater than 1, it is an amplification, increases, and if a is less than 1, it is attenuation, decreases. Okay, here the amplitude is rescaled, hence the name amplitude scaling. Amplitude is rescaled, hence the name is amplitude scaling. Now coming to the time scaling. Time, only there is a changes, increases or decreases in the a for the time function. The time scaling may be time expansion or time compression. Time expansion or time compression. When we'll get it is a time expansion and when we'll get it is a time compression. Okay. The time scaling of a signal, x of t can be accomplished by replacing the t, by at in it. Mathematically, it can be expressed as y of t is equal to x into a of t. Mathematically, it can be expressed as y of t is equal to x into x of a into t. That scaling occurs for the time only. If a is greater than 1, it results in time compression by a factor of a. If a is greater than 1 is a time compression. If a is less than 1, it results in time expansion by a factor of a, because with that transformation, a point at at in the signal x of t becomes a point at t in y of t. Let's take one signal, example signal here, x of t. What is the x of t at -1? It is slowly increases up to the magnitude of 4 at the 0. And it is the same, remains the same at 1 also, and it remains the same at the 2 also. And from 2 to 3, gradually this decreases, goes to the 0. This is a signal given for x of t. Now, with this signal, for this signal, I am taking a 2 is multiplied. 2 is multiplied. Again, I am saying 2 is multiplied. So A is greater than value. A is greater than value. I take the 2. Okay, here the 1 and here the 2. When I take the A is greater than, is a compression. So x of 2 into t. 2 into t. Let you can go in the whiteboard. Given the function x of t at -1, slowly it is increases and constant at the 4, and it is same as in the 1, 2, okay, and decreases at 2 to 3. Write it as a 2 here. Now, to draw the signal with the scaling of 2 into t, A is greater than 1. So here see, at t is equal to -1, x of -1 is equal to, what is x of -1 is equal to 0 here. X of -1 is a 0. At t is equal to 0, what is the x of 0? X of 0, the magnitude is a 4. 4. At t is equal to 1, what is the x of 1? I'm substituting the t value here. These are the t values only. And x of 1 is also the same thing. 4 only the magnitude. 4. And at t is equal to 2, x of 2, the signal is also the 4. Okay. And at t is equal to 3, x of 3 is a 0. These are the values given for the example graphical representation of the signal x of t. Now you have to draw the x of 2t with the sample of 2 as A is greater than 1. A is greater than. So -1, 0, 1, 2, 3 as a t values. Okay. Now I am taking here x of 2 into minus, add the, I'm taking the -1 like this, -1 and the -0.5 also, -0.5 and 0, and in between there is a 0.5 also, and in between there is a 1.5, and in here 2.5. Following my dear students. 2 into -1. Okay, 2 into -1. I'm taking at the -1 value. What is a 2 into -1? X of -2. Is there any value of -2 here? -2 is a 0. So -2 is a 0. At t is equal to -1, I'm taking. At t is equal to -0.5, let it I'm taking -0.5, x of 2 into -0.5. 2 into -0.5. What is the value 2? 0.5 means 1/2. It is x of 2 minus 1/2. The 2 to get cancelled. It becomes of x of -1. What is the x of -1 value here? X of -1 is a 0. X of -1 is a 0 in the given signal. Similarly, the t is equal to 0. when I'm taking the t is equal to 0, x of 2 into 0. The t is, I'm substituting the 0 here. So x of 2 into 0 is a 0, x of 0. What is the value of x of 0 in the given signal? X of 0 is a 4. Okay. Means at t is equal to 0.5, we got x of minus 1 is a 0. This value is a 0 here. And at t is equal to 0, what is the value we got? 4 in x of 2, because this is a signal x of 2. Here is a 4. Okay. Then at the 0.5, at t is equal to 0.5. At t is equal to 0.5, the x 2 into 0.5 means it is x of 1 only. X of 1. What is the value of x of 1? 4. We know here. It is x of 1 and here the 4. So 0.5 also 4 only. And at t is equal to 1, what is the value? 2 into 1 means x of 2 is equal to, what is the value we got? X of 2? X of 2 is a 4. Okay. Value of 4 and here also the 4. So 0.5 is a 4 and 1 is also 4. So it is constant up to the 1. What is the value of t is equal to 1.5? 1.5. The x of 2 into 1.5. What is it? 2 into 1.5? 1.5 means 3 by 2. Means x of 3 it is. X of 3. What is x of 3? 0. So it is at 1.5. 1.5 becomes a 0. See, now comparing these two, the signal is compressed. The signal is compressed to 0.5 and here it is a 1.5. So the signal when the A is greater than 1, they occurs compression. Occurs at the compression. Alright, my dear students. This is a given signal. By multiplying the 2 for this t, substitute the values according to what t is equal to minus 1, 0, 1, 2, 3. And here the x of 2t will get according to the t values minus 1, minus 0.5, 0, 0.5, 1 and minus 1, 1.5. It is compressed the signal. Compressed the signal. Not only the is saying compressed. See here at minus 0.5 and it is getting at the 1.5. Understood, my student? Now if you take the x of t by 2, when I am multiplying, it is compressed. When it is divided means expanded. Expanded towards minus 1 to the minus 2, 3 to the 6. 3 is half here 1.5, minus 1 is half here 0.5, means decreases, not the increases, reduces or compressed. Compressed. If A is greater than 1, it results in time compression by a factor of A. If A is less than 1, the negative value is minus 1, minus 2, the result time is expanded by a factor of A, because with that transformation, a point at 80 in the signal x of t becomes a point at t in y of t. The signal 80 is in the x of t signal, but in the y of t, at a point t1. So there is a compression occurs when it's a multiplication factor. When there is expansion, it occurs when it is a divided t by a and x of a into t. X of a into t is also scaling to the time only. X of t by a is also the scaling only. 1 by a is multiplied and here a is multiplied. The compression occurs when multiplication and expansion occurs when division of a. Understood, my dear students? Consider a signal showing here for a transmission y of t is equal to x of t, the time compressed signal. The time compressed signal. For a transformation of y of t, x of t by 2, the time expanded signal. The time expanded signal. Okay, my dear students. Okay, and up to this basic operations on the signals, we discussed the time shifting, time reversal, and the time scaling. Is there any doubts? Please rise. Okay, thank you to one and all.